Please welcome to the Microsoft Ignite Studio, Azure CTO and Technical Fellow, Mark Russinovich. Mark, how you doing, bud?
Doing good, Seth. How are you?
I see that you have our racquetball helmets behind you. We're on the same team, obviously.
That's right. Yeah, the dark side.
We have T-shirts. The dark side. We wear those. Mark, first of all, congratulations on Sysinternal's 25 years. We kind of did a thing about that. I want to congratulate you again. Did you get a lot of feedback on that?
Yeah, the response was great, and really appreciate you taking the time to do the interview for that.
Awesome. So let's start with the new stuff for Ignite. What are some of the things that you're excited about? I heard some previews of it, but I wanted you to lay the news on us.
I mean, there's a whole slew of things. I think Scott mentioned that we have like 90 new announcements this Ignite, but some of the big ones that I'm excited about, Chaos Studio is a big one, which is our fault injection as a service, something we've been using internally, and now we're making available to customers with growing library of fault injectors to be able to make sure your applications are resilient.
So can we get into that a little bit? Because I want to know kind of a little bit how it works, because I have been known to introduce faults myself, but it wasn't on purpose. How do we do it on purpose and safely so we can test applications?
Yeah, I think that we want to make sure that we do it on purpose before the real world inflicts it on us, and then we discover how our application may handle it or not handle it. And so the idea behind chaos engineering is that you can inject your service or application with kind of nominal faults, the ones that it should just survive every day with, like VMs going down or network ports failing to be accessible. And then you also want to try some of the more extreme things, like the game day scenarios, we call them, which is the ones that are more rare, but you want to make sure your application can survive them, because the uptime of your application during critical events, like the launch of a new product or a big e-commerce day, if you're an e-commerce provider, is critical to your business. And so want to be able to simulate what happens if these large scale events happen in the middle of Cyber Monday, for example.
Yeah, and that's really cool, because I mean, there's certain things that are hard to test, because even when you're testing things and you ship your stuff in containers, there's still like, what if the network doesn't work, or what if the machine shuts down? And I feel like having those knobs to be able to test it is pretty good. Are we using this internally? How are we stress testing the stress tester, so to speak?
Yeah, well, we've been using chaos engineering from the start in Azure, but it's been a lot of homegrown and diverse systems that people have built up around their services. And what we've done over the last few years is consolidate the learnings onto a common platform, which is what we're making available. And so we've been adopting that more and more internally for use. Like Power Apps uses it to simulate their game day scenarios. Azure Active Directory, which the Chaos Studio service is built on the fault injection service that they were using internally for a long time, simulates large-scale incidents in Azure Active Directory. So it's really taking our first-party learnings together and then making it available to customers.
I mean, it's cool how we've used it internally. We're like, our customers might be able to use this too, so why don't we let them use it? I think that's pretty cool.
Yeah, I mean, we've had lots of customers, for example, that have got these applications that they have been asking for. How can we make sure this thing is resilient? We created this DR or HA architecture following the best practices guidance, and but we want to have an easy way to verify that it actually survives these kinds of incidents that we think we designed it for.
That's cool. Okay, so I mentioned briefly about containers. I had to do a Kubernetes thing for a talk, and I didn't know I had 26 hours in a day to learn a thing. Now, Kubernetes is awesome and containerization is awesome, but it was super hard, and there was an announcement today to help us out with that. Can you tell us about that?
Yeah, sure. So that's one of the things that we've seen talking to enterprises, is that Kubernetes is very complicated. And Kubernetes is an infrastructure platform that orchestrates containers, but a lot of people are using it to design applications. Our vision from the start, in fact, we started with paths with cloud services in Azure, has been towards a serverless PaaS world. And so we've been making steps in that direction. This container apps announcements we had today with the preview of container apps is a huge step in that direction, where we allow you to create an application on top of containers, but with the serverless infrastructure underneath and built-in capabilities that are hard to enable if you're just going to raw Kubernetes, like auto-scaling, event-driven auto-scaling on HTTP load, or based on whatever kind of event triggers that you've got to measure load on your application using CADA, which is the Kubernetes event-driven autoscaler that we actually created internally in the incubations team I have here in the office of the CTO, or integrations with Dapper, which lets you leverage the whole ecosystem of bindings, triggers, use service-to-service invocation, have monitoring for all your intra-service operations just built into the platform. Again, another innovation that we created inside of the Azure incubations team based off of learnings that we had with Azure Functions. So it's really a really cool concentration of our learnings and innovation from the last few years in serverless and understanding what enterprise customers want when they're creating a cloud native application.
I mean, that's really cool because, I mean, I know how to run a container on my machine. Are you saying if once I've done it on my machine, a container, it's just as easy as really shipping it up? Is it easy as that, or is there some other stuff you got to do?
No, it's pretty much as easy as that. And we took steps like Azure Container Instances, which was the first serverless container as a service offering in a public cloud. This actually takes that a step further, and it actually makes it much more developer friendly. So supporting event-driven tasks as well as long-running tasks, like I mentioned, what you can test those on your own infrastructure, and you can then deploy them into the serverless environment where you don't worry about the servers at all. You just worry about the auto scaling of the application, the resiliency is taken care of for you, and then these kinds of integrations like CADA and Dapper even alleviate a lot of the overhead that you traditionally have to undertake if you're an enterprise developer and say, hey, I want to be able to auto scale based off certain triggers, or I want to be able to integrate with different storage services and be portable, something that Dapper enables you to do.
And that's pretty cool because my head's exploding because I'm thinking about, well, containers aren't just like web servers. They could be like a batch job that you just want to throw up, or you want to move stuff around data-wise. You can throw one of these containers up and it all just responds lovely, in a lovely way. Is that right?
Yeah, that's right. Yeah.
Oh, okay, so go ahead. Sorry, bud.
Yeah, no, this is, like I said, it's a huge step forward in cloud native development. And I think this is what you're seeing is the future of how do we build resilient apps that are scalable, that are portable, that really take a lot of the burden off of enterprise developers and let them focus directly on just their application.
That's cool. Now, the saying went when I went to school that if you had a problem and you solved it with distributed systems, then you ended up with lots of problems and in the wrong order. When I ship one container here, that's easy. But now as I start to have to ship multiple containers that have to orchestrate, that gets kind of hard. I understand that Dapper is supposed to help with that. Tell us about that.
Yeah, well, I mentioned some of the capabilities Dapper has built into it. Like one of them is service-to-service invocation. So a lot of times so let me actually back up and talk a little bit about how Sidecar works.
Cool.
It is implemented using a sidecar pattern, which means that Dapper's capabilities are provided to your application via an HTTP or gRPC endpoint that is local. So regardless of how your application's architected, your code can always just invoke Dapper services just by calling that local endpoint. And those services consist of different types of building blocks that are aimed at handling different types of tasks and make it easier for you. For example, one of the building blocks is service-to-service invocation, where you can call your different microservices one from another, and Dapper figures out the routing, Dapper figures out retries. So it's kind of best practices as a service built into Dapper. Another one is the actor pattern. So if you've got kind of stateful microservices, it enables you to implement those very easily. Triggers, so you can bind to different triggers and get invoked off of different operations directly from the Dapper sidecar. So your code is kind of abstracted away from the triggers. Bindings, which let you integrate with things like pub subsystems or state stores, like key value stores, in an abstract way. So your code doesn't have to incorporate any SDKs. Your code can remain portable. You can plug in components for different environments. Like I can plug in one for when I'm running on one cloud, another one when I'm running on Azure, another one when I'm running on my on-prem. The code doesn't need to change at all. And best practices on retries and everything else that come with those SDKs is built in to the Dapper sidecar. So it kind of just creates this layer. It kind of stands for distributed application runtime that your application sits on top of and gets all these benefits.
I mean, this is really cool. And this is either going to be the dumbest analogy you've ever heard, and I'll have to wear the helmet extra long at our next racquetball contest. It feels like it's your virtual assistant for distributed systems that you can literally call from your application. Be like, hey, I need to talk to this other thing. You take care of it. Is that a good analogy?
That is a great analogy, and it actually shows that the name that we came up with, Dapper, kind of represents, hey, a butler, dapper butler, dressed up. It's going to handle things for you, kind of. So, yeah, it looks
That's really
like we
clever.
did. Yeah.
Yeah, so I thought I was being clever, but then the whole name, and now there's a top hat. It's like your distributed systems butler that works inside of. I mean, it's awesome. Okay, so here's another challenge that I've recently thought about. When it comes to security and distributed applications, it's actually quite hard. What are we doing in terms of leadership and vision to help security around these types of applications?
Well, regardless of the type of application, whether it's a lift and ship type of application or a cloud native application, we've had a vision, which we call confidential computing in Azure. Back close to when I started in Azure, Microsoft Research was already working in this space of confidential computing, which is based off of what are called trusted execution environments, which are hardware devices or hardware capabilities that create black boxes around your code. So if you think about the way that data moves through a system, it's either stored on disk, and that's where you use encryption at rest to protect its contents, or it's moving across the network, and that's where you use data encryption on the wire, like TLS or SSL. And then what's been missing up to this point is, as I'm processing the data, it's been in the clear. And what confidential computing brings is encryption in use. So these enclaves are created kind of black boxes around your code so that anything around on the outside of that, whether it's the hypervisor, whether it's somebody with physical access to the server, whether it's the operating system, whether it's users that are interacting with the service that the container is part of, they can't see what's inside that black box, and they can't tamper with it either. And so this is kind of the vision of confidential computing that we've got to make the whole cloud confidential. But we're making huge steps, and this Ignite, we're announcing some key new hardware offerings. One is encrypted virtual machines. So we've had encrypted enclaves with SGX offerings in public cloud in Azure. What encrypted virtual machines that we're bringing to market with AMD and their Milan generation of processors in the DC ASV5 series of virtual machines is you can take a whole operating system and run it inside of one of these enclaves and have it protected from the outside environment.
So look, I took an operating systems class, which also proved I had 26 hours in a day to write an operating system. One of the things I don't understand, Mark, is the bits have to go over a bus into memory. How are we? And I know the black box. I've heard of Intel SGX, but that's all on the compute. The compute and the cache, and L1, L2, L3, L4 cache. But what about the actual RAM? Because is that part of the black box? How do we protect that as well? Because you could suck RAM out and learn everything.
Yeah, that's right. So part of it is memory encryption, which is built into these trusted execution environments, right? To be encrypted in use, you've got to have the contents of the data encrypted while it's being processed. And so inside the enclave, the data is in the clear. Outside, it looks encrypted. And when it comes to these technologies, the processors themselves are encrypting the data before they ever leave the die. So if you sniff the memory bus, all you would see is encrypted data. You would not see any clear text data.
Oh, I see. So basically, this enclave, everything in there, it's like the safe space, and everything out there, everything outside of that, everything is encrypted. And even if you had access to the hardware, you literally plugged in wires, you would see encrypted bits, basically.
That's right.
All right, so we have about 60 seconds left. Any innovations down the road, stuff you want to point people to?
Stuff I encourage people to try out the things that we've talked about, specifically on container apps. Like I mentioned, Kata and Dapper are key parts of that. Dapper is fully open source, so is Kata. Kata is actually part of the CNCF as an incubations project. So if you're a developer and you want to get involved with creating this ecosystem, we've had over 1,000 developers contribute to Dapper. It's being opened up for open source governance, and it's being put into a foundation. So it's actually, one of the things that's key to everything we're doing when it comes to innovation like this is making sure it's open and that our customers can take it and use it wherever they want to, and that they can participate in the innovation and contributing to it. So that's one thing I would say is check out container apps, but also check out Dapper and get involved with it.
Fantastic. I mean, I love the idea of having my distributed systems butler to help me out with all that stuff. Thank you so much for being with us, Mark.
All right, thanks a lot, Seth.